My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 169. In this lecture, we will try to understand construction of Anova table with the help of Python code. Let me consider the problem which we were discussing from past few classes. There are three teaching methodologies: Blackboard, case presentation and PowerPoint presentation. Let me say this is teaching methodology 1, this is teaching methodology 2, this is teaching methodology 3. For these two groups of data, for these three samples, we will try to construct Anova table. These are the libraries. We discussed a lot on these libraries. Import pandas as PD, import numpy as np. We discussed a lot on these libraries. Even we have stats model. Stats model is a Python module that provides classes and functions for the estimation of many different statistical models. Anyway, we will try to understand what statistical models we can construct. Just let me assume my file name is oneway.xlx. I stored in E drive. In E drive, in a data analytics with Python folder, where it is in week 5 folder, I stored this particular. This is the path. Just I am storing that. First we will load the data. I am going to save the data in an object called data. This is data is an object in which I am storing this particular file. Print data means just let me display the data stored in that particular file. Which file? oneway.xlx. What is this? This one is 012. This 012 is our index. This is index, isn't it? What are the first column name? TM1, that is teaching methodology 1, TM2, TM3. These are the teaching methodologies. These are the marks obtained by the students, isn't it? This I already discussed about this particular. This one, we were saying this is Blackboard, case presentations and PPT, something like that, isn't it? We discussed about this particular data file. Now my intention is I must construct Anova table. To construct Anova table, I must convert this data into this particular format. How can I convert? We know one particular command, pd.melt command. I discussed what is melt command in initial classes. Just refer my initial lectures on Python so that you can understand pd.melt. Just try to recall that pd.melt. Yes, pd.melt allows you to unpivot data frame from wide format into long format. This is known as wide format. This is wide format. This wide format will be converted into long format, isn't it? Just see what is my teaching methodology 1. Teaching methodology 1 is here. Just see teaching methodology 1. What are the values? 432. Just see 432, isn't it? Therefore, again teaching methodology 2. What are the values? 246. 246. Teaching methodology 3, values 213. 213. This teaching methodologies are known as treatments, and this values, this marks are known as values. To construct Anova table, I need data in this particular format. How can I convert that one? As I told you, I need pd.melt command. Just say this one, data underscore new. This is the new form of data which is in long format. I must convert into long format. But original data, this is original data, it is in wide format. Which one is useful to construct from wide format to long format? pd.melt data underscore dot reset underscore index. This also I discussed a lot about this one. id underscore vars equal index. What is this id underscore vars? This is column to use identify variables. I can identify variables of data frame by using index column. We have index column in original data frame. Value underscore vars. This is column to unpivot. This column only. This teaching methodology 1, teaching methodology 2, teaching methodology 3. These columns only I must unpivot, isn't it? Data underscore new. This is my new data frame name or data object name. dot column means I am adding column names. Which column names I am adding? My first column name is index, second column name is treatment, third column name is values. Just if I execute this piece of code, what will I get? Just see, this will be the desired output. What is my first column name? Is index, treatments, values. Treatments means teaching methodologies, values means marks obtained by the students. Now my intention is I must construct which one I have to construct? Anova table. In order to construct Anova table, first I must model it OLS. What is the meaning of OLS? OLS means ordinary least square, isn't it? Ordinary least square. Ordinary least square. Now I must model. To model what I need, this is value means marks, treatment means teaching methodology, student performance depends on treatments, depend on teaching methodologies. We need which one is dependent variable, which one is independent variable. I am constructing a model in between value and treatments means teaching methodologies. What is my data frame? Data underscore new. Just fit means I am fitting the model. That fitted model is available in model. Now how can I construct Anova table? sm dot stats dot Anova underscore lm. This is model type equal to 1. What is this type equal to 1? Which indicates type of Anova test to perform. Now if I construct this must be the table. This how can I, this particular table is known as Anova table. This is known as degrees of freedom. Whose degrees of freedom? Treatment degrees of freedom. How am I getting this one? Because there are 3 columns. How many columns? There are 3 columns. There are 3 columns means how will I get, what is my degrees of freedom? 3 minus 1. That is 3 minus 1 means that is 2 degrees of freedom for treatments. What about my residual degrees of freedom? Residual degrees of freedom is 6. How am I getting this? For first column, how many values are there for first column? 3. 3 minus 1, 2. How many values are there in second column? 3. 3 minus 1, 2. How many values are there in third column? 3. 3 minus 1, 2. Therefore 2 plus 2 plus 2, that is 6. This is degrees of freedom of my residual. What is this 6.0? That 6.0 is SSB. I already discussed how to calculate SSB in lecture number, I think it's 167. SSB. SSB is 6.0. What is the meaning of SSB? Sum of squares between columns. Sum of squares between columns. I already calculated manually in lecture number 167. Just refer lecture number 167, isn't it? Now, what is my 12.0? My 12.0 is, this is SSE. SSE is 12.0, isn't it? Sum of squares due to error, that is, isn't it? Now, what is this 3? How will I get 3? This 3, how can I get? It is simple and straightforward. This 3 is known as MSB. What is MSB? Mean square between columns. MSB means what? Mean square between columns. How will I get this MSB? SSB by degrees of freedom. SSB by degrees of freedom. What is my SSB? Just is 6. Degrees of freedom. What is degrees of freedom? 2. 6 by 2 means 3. What about this 2.0? My 2.0 is MSE. What is my MSE? Mean square error. Mean square error. How will I get this mean square error? That is SSE by degrees of freedom. What is my SSE value? It's 12. What is my degrees of freedom corresponding to that 6? 12 by 6. That is, I think it's 2. Now, how will I get my F value? What is my F statistic? How will I get F statistic? I can say MSB by SSE. What is my MSB value? My MSB value, just say 3. What is my SSE value? My SSE value, yes, MSE by, I must say it must be MSB by SSE. Where is my MSB by not SSE? It must be MSB by MSE, isn't it? Yes. MSB by MSC. What is my MSC value? It's 2. Just see, it's 2. MSC 3 by 2. Sorry, F equal to, it's not SSC, F equal to MSB by MSC 3 by 2. What is my MSC value? Is 2. 3 by 2 means it's 1.5. This is my F statistics, 1.5. This is P value. I have shown in, I think in lecture number 167. Just refer lecture number 168. Maybe I think we calculated this. Refer 168 or 167. There we calculated P value, isn't it? This is about our Anova table. Even if you want, you can refer your Jupyter notebook once. Just let me show Jupyter notebook once. Just see, same thing, same code which we have written. Just see, this is the libraries, and these are teaching methodologies, and I am melting. How can I melt? pd.melt. After melting, I am storing that melted data in data underscore new. Just see, this is melted data, index treatment value. Just I renamed column names. How can I fit the model? This dependent variable and independent variable. Fit means I am fitting the model. After fitting the model, how can I construct Anova table? Anova underscore LM model type equal 1. What is this type? In model we already calculated. What is type? Type of Anova test to perform, isn't it? That is type. Just let me run this simple code and just let me show this Anova table. This is my Anova table, isn't it? Says this one I already discussed. Just go through this lecture. It is simple lecture. Anybody can understand. If you have any difficulty, please keep a comment. Thank you very much.